Hi guys, I want us to look at this topic that is called approximations and estimations. Now, in this topic, we'll look at the type of questions that come in the exam and how you can answer those type of questions. So, let's go. So, the first question we're going to look at is as follows. So, question reads, Misozi and Filamba estimated the length of a line to be 9 centimeters and 10 centimeters respectively. If the true length of the line was 9.6 centimeters, find A. Misozi's absolute error, B. Filamba's percentage error. Right, so these are one of the few questions that would come on this topic. They would ask you to find an absolute error. They can also ask you to find a percentage error. But how can you find any of those? So I'm going to show you just how you can find such. So to begin with, how do we find absolute error if we have been given the true measurement? So if you can see here, they've given us the true length. So the true length has been given. So if they've given you the true length, so this is how you can find the absolute error. So we're going to do this. We say they've given us an estimated value. So our interest here is Misozi. So they are saying Misozi was the first name that came, and the first number that came was 9 centimeters. So this simply means the estimated value that Misozi had was 9 centimeters. So if you just find the difference between two, so in order for us to get, so I'm going to abbreviate, so part A, in order for us to get the absolute error, we are going to get the difference. So we're going to get the difference between the two values. So in getting the difference now, we're going to say which one is a bigger one, subtract the smaller one. So the bigger one was the true measurement. So we're going to say the true measurement, or I can say the true value, subtract the estimated value. So the true value in this case was 9.6 centimeters. Then the estimated value was 9 centimeters. So you subtract these two, what are we getting? We get 0.6. So we're going to get 0.6 centimeters. So what I've gotten here now is the absolute error for Misozi. So that's how you can do that. If that's how you can find the absolute error if you've been given the true length. But there is another way that you can find absolute error, and we're going to look at that shortly. Let's look at part B. We calculate Filamba's percentage error. How can you find percentage error? Percentage error, so I'm going to abbreviate it as this. So percentage error is given by the estimated value. So we're going to say the estimated value, in this case we're looking at the absolute error. So the estimated value, we subtract that. So let me just say, we say the absolute error, so we're trying to get the percentage error. So we say absolute error divided by the true measurement, or you can say the true value. Then we subtract, we multiply by 100 since we're looking for the percentage. So how do we find the absolute error for Filamba? What we're going to do is we're going to look at what was the estimation for Filamba. The estimation for Filamba was 10 centimeters. This was the estimation. Then the true measurement was 9.6 centimeters. So we're going to get the difference between these two, and that will be our absolute error. So the difference between the two will be the bigger number subtract a smaller number. So we're going to say 10 subtract 9.6. Then this is going to divide the true measurement or the true value. The true value is 9.6. Then we're going to multiply by 100. Okay, what is 10 minus 6? So we continue it from here. So 10 minus 6, we're getting 0.4. So 0.4, that is 10 minus 9.6, I mean we're getting 0.4, then divide by 9.6, then we multiply by 100. Okay, so what do we get now when you do this? So we're going to say, what is 0.4 times 100? 0.4 times 100, we get 40, because we have here the decimal point is going to move 1, then it will be 4, then the other one, so it will be 40. So this will be 40, then down we're going to have 9.6. So what do you do when we say 40 divided by 9.6? I hope you are able to do this kind of division, because this type of question does not allow you to use a calculator. But if you don't know how to do this kind of division, you can comment in the comment section. Then I'm going to make up a video on how you can divide decimal numbers and non-decimal numbers, so that you'll be able to answer paper 1 type of questions. So if you divide that one, I'm going to leave that one as a fraction. So if you divide that one, you're going to get 25 over 6 as the lowest fraction. So this is in its lowest form. So 25 over 6%. So that is how you can find the percentage error. So the key part was that in order for you to find the percentage error, you get the absolute error over the true value and you multiply by 100. So once you do that, then you are well and good. Then what I want us to do, we're going to look at a different question so that we can compare with what we've done. So let's look at question 2. Question 2, there we go. So what is it that they're requesting us to find in question 2? Let's read the question. A bag of potatoes has mass. So this is the mass. So we are saying 15.4 plus or minus 0.05 kilogram. If they give you a number in this form, so whenever they give you a number in this form, this simply means the first number that comes. So the first number that comes is always the true value. So the first number that comes is always the true value. Then the number that comes after the plus or minus is always the absolute error. So this is the absolute error. So we have the true value and we have the absolute error. So you have to be very careful here. So let's proceed. The question is saying find the part A tolerance of this mass. So how do you find tolerance? So let's start from there. How can I find the tolerance? Now to find tolerance, I think this is one of the simplest on this topic. So to find tolerance, this is what you do. So we have that tolerance is equal to, we get the absolute error, then we multiply it by 2. It means you found tolerance. So what am I going to do? So to find tolerance, I'm going to get what is the absolute error. The absolute error was 0.05. That was the absolute error. Then I multiply it by 2. So what is 0.05 multiplied by 2? Hopefully, I also hope that you also know how to multiply decimals. If you are good, then well and good, because this type of questions do not allow you to use a calculator. So if I multiply that, because I know when I say 2 times 5 is 10, alright, then I'm looking at the number of decimal places. So they're going to move. I've got 10 here. Then there are 2 decimal places. So starting from here, it will move 1, 2, going backwards. So it will be a point to be somewhere in front of 1. So it will be 0.1. But if you're having challenges on how to multiply such, you can let me know. So 0.05 multiplied by 2, the final answer is 0.1. So 0.1 here is our tolerance. That's how you can find tolerance. Let's look at the other one. How do you find the relative error? To find the relative error, this is what you do. So I'll abbreviate it as RE. Relative error is given by this formula: absolute error divided by the true value. So what is our absolute error? If you check in here, we said our absolute error was 0.05. So 0.05. Then what is our true value? Our true value is what? Our true value is, let's check, it was 15.4. So our true value was 15.4. So when you divide these two, you are going to get, now we're going to leave it as a fraction because it will be difficult to leave this as a decimal. We can easily get rid of the decimal place, of the decimal point, then we leave it as a fraction. So when you reduce this, the final answer will be 1 over 308. So 1 over 308. So like I said, if you have challenges on how to divide decimals, you can let me know, then I can just make a separate video on how to divide and multiply decimal numbers. But if you are good to do that, you can do this and then you can find that. And I think it's important you do that so that it will be part of you showing your work instead of just going to the final answer. Yeah, so you should show how you're going to find this 1 over 308. I think this is going to help us. So but I will leave it here. Let me know if you have challenges on how you can do that. Alright, so now let's look at another question so that we can cement our understanding on this topic. We have that question. We have part A and part B. How do we go about that? So the question reads: the mass M of a block of wood is 876.4 grams, correct to 1 decimal place. Complete the statement in the answer space below. Alright, now look at what is happening here. We have M as our mass there, so that is M that we have here. Then we are saying M is greater than or equal to, so we have that. So and M, so there's a number here, so M is greater than or equal to dash. We don't know the number which is supposed to be there, and M is less than or equal to a certain number here that we don't know. So they want us to complete this by putting a number here and a number there. So what this simply means is that they want us to complete the statement without changing the actual value of this when this has been rounded off to 1 decimal point. Okay, how do you understand this question? We have the value. This value was rounded off to 1 decimal place. So what do you think was this value before it was rounded off to 1 decimal place? So let's give some suggestions. So I would suggest that before this was rounded off to 1 decimal place, it was something like this. It was 876 point let's say 35. So 876.35. Now look at, have you seen this number 876.35? If I'm to round off this one to 1 decimal place, this 5 is going to donate a 1 here and it will disappear. So this will become a 4, which is the 4 which is there. So have you seen? Then if the other way I can look at this is when you have something like this, 876.44. Now look at this again. So 876.44, the 4 here, if I'm to round this one off to 1 decimal place, the 4 here which is at the far end is less than 5. Therefore we cannot donate a number here. We cannot donate a number here to 4. It will remain 0.4. So we are seeing that in either cases, so we would have picked on 3.5. So I cannot pick less than 5 for this scenario because if I pick a number which is less than 5, it means the 3 will not be 4. Have you seen? So I can pick on a number which is above 5, but we're looking for a number that I'm going to start with. So it starts with 5. So you put a 5 there. The 5 is the one that is going to make this 3 to be a 4. You've seen? Yeah, so that's the first digit that you put. Then when you come down, you check here. If I put a number which is greater than 4 here, this 4 will be affected to be 5. So if I put a number which is less than 4, the 4 will maintain, but I'm looking for the highest number that I can pick here. So you get both the lowest and the highest. So here I picked on the highest number that I would get, because from the numbers, let's say we have a 0, we have a 1, we have a 2, we have a 3, we have a 4. So you can pick on any number here and replace it in place of 4, and the 4 which is here is going to maintain. Then on this other end, we have a 5, we have a 6, we have a 7, we have an 8, we have a 9. You can pick any of these numbers and replace in place of 5, and you're going to discover that this 3 will change to 4. But what are we looking at? In the first scenario, we're looking for the smallest. Then in the second scenario, we're looking for the highest. So no wonder we're looking for a number that is going to start, which is a small number, and a number which is going to end, which is the highest number. But the bottom line is that if you round off to one decimal place, the final answer should be 876.4 grams. So here the smallest number I'm going to write here is 876.35. So I'll start with 0.35. This will be the smallest. Then the biggest is 876.44. So that is how you can look at that. So you just have to find the highest and lowest possible numbers. So once you do that, then you get that one. Let's look at the other question. The length of a piece of wire is measured as 15.2 centimeters, correct to one decimal place. What is the relative area of the length of the piece of wire? Now remember, we had looked at what relative area is, how to find relative area, which we denoted as RE. I said relative area is given by the absolute area, then divided by the true value, like that. So now how are we going to do that? So we have the length here, so which is 15.2, correct to one decimal place. Now what you're going to understand here is that we've only been given one value here, which is 15.2. So it's kind of difficult for us to find the absolute error by subtracting it. We've not been given any estimations. We've not been given any estimated value. As you would see in one of the examples that we looked at, let me just take you back. In this example, we found the absolute error by getting the difference between the true value and the estimated value. But in this particular case that we are looking at, we don't have any estimations. So how do you find the absolute error if you don't have any estimation? So this is how you find the absolute error. Let me do it here. So the absolute error is given by half of the least unit of measurement. So absolute error is given by half of the least unit of measurement. So I'll say half. Then what is the least unit of measurement? Now this is how you can find the least unit of measurement. So the least unit of measurement from a number that has got one decimal place is 0.1. I know some of you might have challenges on this one. Let me just give you this scenario. So any number that doesn't have a decimal point, so you can have a number from 1 all the way up to 100. Sometimes it can even be more than 100, any number. So any number at all any number at all that doesn't have a decimal point, its least unit of measurement is 1. So the least unit of measurement is 1. Then now, a number that has got 1 decimal place, the least unit of measurement is 0.1. Then a number that has 2 decimal places, its least unit of measurement is 0.01. I hope you are getting the trend in here, what I'm trying to arrive at. A number that has 3 decimal places, its least unit of measurement is 0.001. So that's how you go about it. So when you take this number 15.2, how many decimal places does it have? It only has 1 decimal place. Therefore, its least unit of measurement will be 0.1. So what is half times 0.1? So if I say half times 0.1, what am I getting? So you also need to know how to multiply a fraction and a decimal. So if you don't know how to do that, you can let me know, and I'm going to make a separate video for you so that you can be helped. So what is the half times 0.1? So half times 0.1 is 0.05. So 0.05. That is the half times 0.1. So we come here and we say our absolute error, we found it. It is 0.05. Now that our absolute error has been found, then we now get our true value. So what is our true value? Okay, in short, the value that has been given. So we call that one the true measurement. So the true value is 15.2. So that is our true value. So now if you divide these two, what are we supposed to get? Again, that is another concept on dividing decimal numbers. So you should show without using a calculator how you're going to divide these two numbers. So you show how you're going to divide these two numbers, then you find the actual value. But I'm just going to give you the final answer, and if you are going to have any challenges in deriving the final answer without using a calculator, you can let me know, and I can do some videos on how to divide decimal values. So the final answer should be 1 over 304. So the final answer should be 1 over 304. So that is how you can go about such. I hope you've gotten 1 or 2 concepts on this topic. Hopefully you are going to answer almost all the questions that will come on this topic. But before we can break off, let me give you some questions that you can try. So if you can get these questions, you try them at your own free time and see how you are going to attempt these. Okay.